Section 2, the organs of the respiratory system, mostly going to be looking at structures here. So the organs can be divided into basically two main groups. The upper respiratory tract, which would be your nose, nasal cavity, sinuses, pharynx, the top part, and the lower respiratory tract, which would be the larynx into your trachea, bronchial tree, and then branching out into your lungs. So it's broken into two groups. So here you can kind of see this would be more of the upper tract. This would be more of your lower tract. And labeling, I guess I can look at some of these. Some of this we've had before, so oral cavity, pharynx, esophagus, remember, runs behind your trachea. Your pharynx is above your larynx. We'll talk more about the larynx this chapter. Trachea, and then it's going to branch into your lungs. Nose, supported by bone and cartilage. Talked about that a little bit in the skeletal system. It basically produces an entrance. That's where air comes in. Air is filtered. That's the purpose of your nose hairs, is to help catch things. And that inside area of your nose is the nostril portion. Nasal cavity then is the space behind the nose, and it's divided medially by the nasal septum, and we did talk about that in the skeletal unit as well. Nasal conch or conchae divide the cavity into many passageways that are lined with a mucous membrane. They help to increase surface area. They're bumpy, they're rigid, available to that to help warm, moisturize, and filter air. Mucous membrane, that mucus is very important in helping to trap small particles. And then the particles that are trapped in the mucus are carried to the pharynx by a ciliary, little hair-like action, swallowed and carried to your stomach, where gastric juice destroys the little organisms that are caught. And I'm guessing you probably didn't know that part. Here again, another picture. You'll be labeling these. Some of this we've seen before. Remember, the nasopharynx is up on top. Oro deals with mouth. Laryngopharynx sits below by your pharynx, or your larynx area. So a lot of this picture is actually review. The only thing, the nasal conch, you can see those folds in this area. I don't believe we looked at that last chapter. Here it just shows inside, so that cilia that I was talking about, on the outside of the cells, these little hair-like cilia are what help to move those very small particles. So the lining of your most of your respiratory system, epithelial cells, goblet cells that are going to produce mucus, and then the little cilia that sits on top. Paranasal sinuses. Sinuses are going to be any air-filled space. There's the maxillary, frontal, ethmoid, and sphenoid sinuses, and they're named after the bones that they sit inside of. Those spaces open to your nasal cavity. They are also lined with mucus. Basically, the purpose of sinuses is to reduce the weight of the skull. Kind of like birds, if you've ever heard bird-brained. Basically, the reason birds have that saying is because their skull is very hollow. Our skull is not as hollow as a bird would be, but if our skull was completely compact, our head would be extremely heavy. So the sinuses are one way of having hollow spots that reduce the skull, and then it also is, kind of like almost a music room, and the resonance that you have in the background, it helps to affect your quality of voice. But the main purpose would be to reduce some of the weight. Pharynx is that common passageway for air and food. So both are going to pass through the pharynx. The pharynx, like I said, very important for speech. There's 3 subdivisions, and we've talked about this before. Naso deals with nasal, oral, mouth. Laryn deals with the larynx area. So that just breaks the pharynx into 3 divisions. Exact same picture. Don't need to look at that again. The larynx then is an enlargement. It actually opens further. So it's an enlargement in the airway, and it sits above the trachea and below the pharynx. Basically, it's going to keep particles from entering your trachea, and it also houses your vocal cords, which gives it a very specific job that it does. Larynx is composed of muscles and cartilage that are bound together by an elastic tissue. Your thyroid and then cricoid cartilages are made up of hyaline cartilage. And then the epiglottis, the flap that keeps food from entering your airway, is also elastic cartilage. So here is a picture. So if we're looking at the front, your hyoid bone would be up here. Thyroid cartilage is going to be the larger of them. And then cricoid cartilage sits below. And then your trachea is going to have those little cartilage rings that wrapped around it. And then this would be looking from the back, and this would be your lower cricoid cartilage, and then your thyroid cartilage sits in front and on top of the trachea. Inside the larynx, there's 2 folds or 2 pairs of folds of muscle and connective tissue that make up your vocal cords. And we'll look at a diagram of that. The upper pair is called false vocal cords, and then the lower pair is the true vocal cords. And what happens is the changing tension on those vocal cords control pitch, the pitch of your voice, while increasing the loudness depends on how much air you push through those vocal cords. So everybody's vocal cords are different. Mine obviously have quite a bit of tension on them because I have kind of a high-pitched voice. If you would look at our math teacher, Mr. Danik, I assume his are not as tense because his voice is much lower. In order to talk louder, you push more air as you talk. And you notice that, if I were to talk for 50 minutes to an entire classroom, I would be tired because when you're talking loud, you force a lot of air through. The pharynx, oral cavity, tongue, and lips are also very important into forming your words. So basically, your vocal cords control the pitch and they let air out. It is your mouth, your tongue, your lips that help you to actually form words. So basically, when I'm talking right now, my vocal cords send air. It is my tongue and my mouth that make it sound like I'm saying different words instead of all just the same thing. Another thing with that, I have a friend talking about that tension on your vocal cords. And your vocal cords, when you talk, kind of open and close. For some reason, and she was probably late 30s, early 40s, and her vocal cords paralyzed open. So they don't close. So when she talks, like the air she runs out of air because they don't ever close. So when she talks, it's almost, she might sound loud for a split second, but then it's like she's whispering because she cannot get the air to keep coming out. Normal breathing, vocal cords are relaxed. The glottis is a little slit that's located. We'll look at a picture of that. And then during swallowing, when you actually have food in your mouth and you're swallowing, the false vocal cords and the epiglottis, close that off so that you don't get any of that food into your air passages. So here, if you've ever seen a video, this is like a microscopic picture. It's very, you can tell when you look at anything that's respiratory, it's very shiny because it's full of mucus. But basically, you can just see this open and close as someone is talking. So here you can see the glottis is that opening or cavity that's going to end up going into your trachea. So when it's closed, it's going to keep things from falling. And then you can see false vocal cords are this outer part, and the true vocal cords are the inner part that actually open and close. And I will stop there and take a break.